Hey guys, this lesson goes with lesson 4 in your book. But before we get to the actual book work, we're going to do kind of an exploration of what the fundamental theorem of similarity is. Now, I know that's a lot of words and we have no idea what it's talking about, but we're going to start just kind of exploring stuff and you'll actually see that you kind of know a decent amount of what we're going to do. Okay, so for this exploration, you need a piece of lined paper and a ruler. Okay. So what I want you to do first is plot what's going to be our center of dilation. So somewhere on your piece of paper, kind of towards the top, I want you to make point O, which is going to be our center of dilation. Okay. Then what I want you to do is we're going to plot a point P somewhere on this piece of paper. So yours can be different than mine. Okay. So if you want, I want you to just kind of count by lines on the paper. So make point P either like 3 lines down, 2 lines down, 4 lines down, something like that, and somewhat off to the side. So I'm going to make point P right here. 1, 2, 3 lines down and just over a little bit. Okay, again, yours could be 2 lines down, 4, whatever works for you. Okay. So now what I want you to do is we're going to draw a ray from O through P. Okay, we're going to draw a ray from O through P. So P is going to be our original point, and we're going to dilate it, so we have to draw a ray all the way through here. Okay. So we now want to mark P prime, and again, we're just kind of choosing where we want to put it. We'll find the scale factor and all that later. Okay, so somewhere along this ray on a paper line, I want you to mark where you want P prime to be. Okay, so I'm going to make it here. Again, that's my choice. I could have put it here, here, whatever. Okay, just somewhere along the ray and on a lined line, put P prime. Okay. So now we know from our work with dilations that this original length OP was dilated by some scale factor to become OP prime. Think about it. Was this scale factor greater than 1 or less than 1? Based on what we've done so far, what do you think? Hopefully you're thinking that it was greater than 1 because P moved further from the center of dilation and the segment OP was getting bigger in size. So whatever our scale factor is, it's definitely bigger than 1. Okay? So now what we're going to do is create another point and do the same thing to it. Okay? So somewhere along on these lines here, I want you to make it so that it sits on the same paper line as P. We're going to make point Q. Okay, so we're going to make point Q somewhere on here. Okay, so I'm going to put mine here. Again, yours can be over here, but as long as it's on the same paper line as P, we're fine. Okay, so now we're going to do the same thing. We want to dilate this point Q, so I'm going to draw a ray from O through Q, nice and far. Okay, so then now what we're going to do is the same thing. Okay, so we want to use the same scale factor to dilate Q as we did P. So I want you to plot Q prime on the same paper line as P prime, but on the ray itself. So this would be Q prime. Okay, so now I want you to connect PQ and P prime, Q prime. Whoops. Okay, so we connected those two. All right. What do you notice about PQ and P prime, Q prime? Okay, think about what do you notice? Well, both of them lie on the notebook paper lines, okay? And how are notebook paper lines designed? They are parallel, Okay, so we see that PQ and P prime Q prime are parallel lines because of the fact that they lie on these paper lines. Okay. Now, you don't have a protractor at home, but I do. So what I'm going to do is measure this angle here and this angle here. What I want you to do at home is think about what I should find when I measure both of these angles. Okay, think about what I should find when I measure both of these angles. Okay, so here I'm getting about 48 degrees. Okay, and here I'm getting about 48 degrees. Okay, so what do you notice? What's going on with these angles? Well, you should see that, well, they're the same. Okay, they are the same angle measure. What about if I do this angle here and this angle here? What do we think happens? Let's take a look. So I'm getting about 70 degrees here. And look at that, 70 degrees here as well. Okay, so why is that happening? Why are we seeing the same angles on this line here and this line here? Why is that happening? Well, you should remember that dilations preserve angle measurements, okay? So if the relationship here was 48 degrees to begin with, and then we dilated it out, who cares what the scale factor is? It's still going to preserve those angles, okay? Also, if you want to think back to all of our angle work, if you kind of picture, okay, this line, looks like this, right? And we have this here. We have 48 degrees and 48 degrees. What kind of angles are those? Do you guys remember how we would describe the relationship between those angles? Well, they're corresponding angles on parallel lines, and we know corresponding angles when lines are parallel are always the same. So that goes back to all of our angle work, why this thing holds true. Okay? All right, now what I want you to do is get that ruler out again. We're going to measure OP and OP prime. So we're going to measure two segments here. Okay, so with the centimeter ruler, OP is about 3.6 centimeters for me, but yours might be different. So OP is about 3.6 centimeters. Okay, and then I'm going to measure OP prime. For me, this is about 8.2 centimeters. Okay. So how can we figure out what the scale factor must have been knowing these two lengths? So I know this is 3.6 and I know this whole thing is 8.2. How can we use this information to find what the scale factor must have been? Think about that for 1 second here while I turn the lights back on. Okay, well, we know this original length OP had to be multiplied by some scale factor to create OP prime. Okay, we know OP is 3.6. We don't know our scale factor, but we know OP prime is 8.2. Okay, so if 3.6 times something is 8.2, how do you figure out what that something is? How do you work backwards in multiplication to figure out what that is? Well, you divide, okay? The opposite of multiplying is dividing, okay? So I could divide this by 3.6, divide this by 3.6, and let's see what we get. So we have 8.2 divided by 3.6. We're getting a funny number, okay, which is fine because we did this just by freehanding it. It was our choice. There was no rhyme or reason as to how we created this. So let's call this 2.3. Okay, let's round this to 2.3. So our scale factor was 2.3. Okay. All right, so now I want to do the same thing over here. I want to measure this, OQ and OQ prime. Okay, so same thing in centimeters. I have OQ is approximately 2.8 centimeters. And again, yours might be different. Okay, so this is about 2.8 centimeters, and now I'm going to go ahead and measure OQ prime. So I'm getting about 6.4 centimeters. Okay, so this was 2.8, and then this whole thing here was 6.4. Okay, so to do this, same kind of thing. I want to know what scale factor brought an original segment that's 2.8 to now be 6.4. Okay, so same process. I know OQ was dilated by some scale factor to become OQ prime. I know OQ is 2.8. Don't know the scale factor, but I know this is 6.4. So we just said to do the opposite of multiplying, we would divide each of these by 2.8. Okay, and let's see what we get. Whoops, a little bit of a glare. Okay, so we get funny number, but we can round that to about 2.3. Okay, what do you notice? What do you notice here? Hopefully you're seeing the scale factor was the same. We got the same scale factor, even though we just did this completely freehand. There was no rhyme or reason as to where we put our points. We just made sure that these segments were parallel. That was all we did in creating this, and the scale factor still ended up being the same. Okay? If we were to keep going here, if I measured PQ and P prime Q prime, what do you think you'd see then? Do you think the same scale factor of 2.3 would take this and turn it into this length? Well, yeah, we would, okay? It's the same process, okay? So this is what we call the fundamental theorem of similarity, is that if you create parallel lines between points that were dilated, so original dilated, okay, all this stuff starts to happen. Angles are the same scale factor brings OP to OP prime, as does OQ to OQ prime, and here to here as well. Okay, so I want you to use this understanding to now go ahead and work through the lesson 4 classwork, which starts on page 37 in your book and goes to page 38. Okay, so I want you to give that a try, and then when you're done, if you feel comfortable, move on to the problem set, which is on page 48. You're going to do 2 and 3 for homework. Okay, so get comfortable by doing the classwork. Ask me questions if you need. And then once you're comfortable, do page 48 for homework.